Exercise 11F looks at the area underneath a curve, or the area between the curve and the x-axis. There's three scenarios that we're going to look at. We're going to look at when our entire function is above the x-axis, when our entire function is below the x-axis, and then also looking at when it crosses the x-axis. So scenario 1 is when the function's above the x-axis and we're trying to find the integral, or the area between a and b. So the f of x is above for both portions of this function. So between a and b, the function is entirely above the x-axis, which just means that we're going to find the integral between a and b. We're just not going to do anything with it. It's perfectly fine as is, and we're just going to calculate this. Scenario 2 is looking at when our function is entirely below the x-axis. So between first interval of a and second interval of b, f of x is entirely below the x-axis. And as such, it's going to be a negative area. So the area there is negative, which just means to make sure that our area is positive, because negative area doesn't actually make sense. So to make our area in here positive, we're sort of going to reflect it or multiply it by a negative. So it's like saying we've moved it so that it's all the way up the top. This is the same, or it's equivalent, to having found the interval, or the definite integral, having switched our limits. So instead of having a at the bottom and b at the top, we can do b at the bottom, a at the top. This is exactly the same as having done a negative out the front. So you can choose one or the other. It doesn't matter which one you choose. Don't combine them together. That won't work. The last scenario that we're going to look at is when the function exists both above and below the x-axis. So the first part we look at is the above. The above's just always easier. So we look at that x-intercept at c, and that's going to be our lower limit, and then b is our upper limit. And we do our normal integral of f of x in that region, or for that region. So that's just a positive area. It's nice and simple. We don't have to worry about that. We're going to add that to the next section. The next section is between a and c this time. This section exists below the x-axis, so it's actually going to be negative. So we've got to actually, I suppose, register that it's negative and then take into account that it's negative. Hence, our function up the top here is multiplied by the negative. Now, this is the same as just reflecting our function. That's what a negative out the front does. It just reflects it. So I could draw in my function like this. I've just done that. And then it's like finding the area above. So if I find the region that I'm shading, that region there is equivalent to the region that's below. So I've got the same size region. It's just now existing above the x-axis because I've done a reflection. So I'm interested in the area between the x-axis and the function, and that exists as a positive here, not a negative.